Hello, Paige.
Hello, Professor. How are you this morning?
Just fine. Do you have souvenirs for me?
What sort of souvenirs are you talking about?
Programs.
What are you, what ones? I don't know.
I asked you yesterday for a program. Have you done it?
No, I have some of the code. I am very sick right now and not doing well.
This is the program I asked about. It is about, I believe, here we are. Shift register. That's what we spoke about yesterday, and you are supposed to finish it. Do you have it ready now?
No, I have been very sick the past couple of days, so I haven't been able to do a whole lot.
You were here yesterday and you attended the class and you worked on it in class. And you should have
I
finished.
attended the class, but I did not do anything. I just listened to the lecture.
So you didn't even type anything during the class?
No, I did not.
Hey, Professor, can I change the subject just for a second?
Okay.
For next EE333, there is a group project, and I'm kind of the only guy up here in Portland metro area. So would it be possible if you could give me like 5 minutes to talk to you about what to do and maybe do that one on my own? Just because I'm doing nights and also like working nights, and it probably wouldn't be fair to give somebody like a lab partner to me just because I'm so busy.
I have no problem if you work alone.
Okay, thanks, boss. And then I would need, because like, is there a place in which lecture where you talked about what are the requirements or what you want to see for that group project?
No, I want to see you using many of the sensors and many of the
All right.
commands that we used in the class.
Cool. Thanks, boss.
But I need to approve it before you start.
Um,
Send it to me by email.
I'll try and get that done probably Wednesday if possible. We'll see.
Because Thursday, you are
Yep.
going to make a demo.
Yes, sir.
Okay, thank you.
Yeah. Cool.
Back to Paige. Do you know what to do?
I just type in the code, right?
Yes. Do you know what to do? What this code will be doing? How to do it?
Yes, doesn't it have a shift of 8 and the generic part repeats it 8 times?
Yes. And we have to create another file external that is called shift register that will be called.
Okay. Okay, sounds good. Thank you.
When could I get it from you?
I can try to finish it today.
Yes, because tomorrow is our second quiz.
Okay.
Okay. Cameron Castello.
Yes, Professor.
You didn't call me.
I just saw that email when I got here. I apologize.
Okay. Chad,
Yes, Professor.
You are done with this program,
Um,
the shift register with generic.
yes,
generate?
correct. Yes, I finished it on my desktop at home. I'm currently at campus right now. But what I did instead of the D flip-flop, I used, or I'm sorry, instead of the shift register, I just used one of our homeworks, the D flip-flop with enable. I used that and it worked fine.
And you are sure you used the generate statement?
Correct. Yes. Yes.
Yes, this is the key thing, is to use the generate statement and to call an external file.
Yep. And it worked.
Okay. Now I'm going to speak about switch bouncing. If I have a switch like this switch in here, it has an internal spring, and the spring prevents the switch from latching immediately and staying in position. It will oscillate. These oscillations are taking a very, very short time. But for our system, it will think that it's on, off, on, off. Can you see the switch debouncing here? Going from high to low, and another switch bouncing going from low to high. This, of course, would give you invalid data. So we need to avoid this switch bouncing by making a software to take care of this. The software, it is under the family of switch debouncing. For this switch debounce, I have here my push button. It is going to a first D flip-flop. And this D flip-flop is feeding another D flip-flop. So I have two cascaded D flip-flops, and they are using the same clock. What will happen here? I have the first one, high. This high will be reflected in here. And after one clock cycle, it will be on the next flip-flop. First, the flip-flop. And this is the second. This is one, this is two. For the first flip-flop, with the rising edge of the clock, I will get high. Let me put the input signal. This is my input signal. In this input signal, maybe I missed the first one. So here with the rising edge of the second clock, I have the signal available. So this Q0 and this is Q1. So here Q0 will go high. The second clock, Q0 is high. With the third clock, I don't have Q0. It will go down like that. Now, suppose that I'm looking for Q1. What will happen to Q1? Q1 is sensing the output Q0. This will be D1. So I will start getting an output here. I will miss the first one, but on the second one, I will start getting the output. And when I go here, I don't have anything, or I have this, so it will extend one more time and end. Now suppose that I have some oscillation, bouncing of the switch. Bouncing of the switch, yes, it is not as straight as this green one. No, I am having some bouncing here. This bouncing, it will reflect the first one. I missed it, but the second one will hit the second clock, this clock. So I will go down. But I have my Q1. It is not going to follow it immediately. So my circuit over here, this is my circuit. It is taking the output of Q0 and Q1 and making an exclusive OR. What is this exclusive OR is doing? This exclusive OR, it is just simply saying if Q0 and Q1 are not identical, the output will be 1. The truth table of exclusive OR. The output here, when those are not identical, I get output high. If the two inputs are identical, I get 0. How could we use it here? We used it here. I am comparing the two outputs, Q0 and Q1. If those are not high, I have this n-bit counter clear. It is not counting anything, nothing. Now, what will happen if those are identical? I don't have a clear command. The counter is free to start counting with the clock. It is preset to a number. This number says, for example, if those two are identical, so no clear, counter is free to start counting. It will count from 1 to 1000. So I have 1000 clock. 1000 clock that will ensure that this oscillation is gone. If I have a matching between the two D flip-flops for 1000 clock cycle, that means I am very well stable, either high or either low. The n bit counter is set to a number. I am giving you an example. It is 1000, and I'm going to tell you next how to select this number. Now, this n bit counter, it is counting up, counting up. When it reaches its terminal count, what will happen? I will get C out high. This will enable my third flip-flop. When it is enabled, the third flip-flop will sense the output of flip-flop 2 and push it out as a result. So this is my stable result.
I have a question.
Yes, sir.
So I see here you have 3 flip-flops, yes?
Yes.
So let's say you had more flip-flops. Would you have to provide more of these counters in between to detect this switch bouncing?
No, this whole system, it is for one switch only.
I see. Okay. So you only need to have one of these n-bit counters.
I need to have one of these for each switch you use.
Okay, perfect.
Okay?
Yes, thank you.
Thank you. So when I guarantee flip-flop 1 and 2 are giving the same output, the clear command will vanish and the counter will start counting. This counting, it is a time delay. You can say it is a time delay to make sure that those 2 flip-flops are the same for a certain time. When I reach the terminal count, I enable the third flip-flop that will copy whatever Q2 is and push it to the out. Okay?
So Professor, if the exclusive OR gate was to recognize, say the same input from flip-flop 1, flip-flop 2, so either 0, 0 or 1
Yes.
and 1,
Yes.
it would output 0 to the clear.
This will put 0 to the clear if both are the same. When
so-
you put 0 to the clear, that means don't clear.
Right.
Don't clear.
The clear.
If I
optional,
don't
right?
clear, that means the counter is free to count.
Okay, perfect.
But if I have discrepancy between flip-flop 1 and flip-flop 2,
Mm-hmm.
the exclusive OR will give you high. It will clear the counter. The counter will not count. Even if it starts counting, then there is a glitch. It will clear and wait to start from 0. I need to get stable counting, stable input.
Mm-hmm. And I'm looking at this little counter schematic you have, and the C out is connected to your enable.
This is connected to the enable, yes. And
but also to the enabler.
When I reach the terminal count, C out will be high. And when it is high, it enabled flip-flop 3. Otherwise, flip-flop 3 is dead, doing nothing. When it is enabled, it will take D, push it to Q. D3 will go to Q3.
Maybe this is a silly question, but if you have a 0 coming into the clear, and so there's no clear, and it's free to count, where is it getting that signal to count? Because I see the enable on the actual counter has a bubble, so it's a inverted signal.
Just a moment. This clear is 0.
Right.
And this one, it is counting.
Mm-hmm.
And C out has nothing, so it is 0.
Oh, I forgot that it's also clock dependent. Never mind. Okay, perfect.
Yeah. It is 0 now, and it is enabled when low. When zero, this counter is enabled.
Perfect.
But when it goes high, to push D3 to Q3, now the enable will be high and will be disabled.
No, that makes so much more sense. Perfect. Thank you.
Thank you. Samuel? Hello, Samuel?
Hey, what's up, boss?
Yes, sir. Would you please tell me how this switch debouncer works?
So I'm pretty sure that you can have F1 and F2 are basically memory slots, I think.
Yeah.
And then you run it through the n bit counter.
First of all, what's the function of flip-flop 1 and 2?
To store the last bit, I think. Is that right? So to store it, like you said, it has a delay, a slight delay. Or am I missing you? Am I not getting your drift here? I haven't had coffee
I
yet.
have here this is a very long signal. This is clear. It is very high for long time. And this is my oscillating clock. For flip-flop 1, with the second clock, it will go high and remain high. For flip-flop 2, it will follow the same thing, but after 1 clock cycle. During this time, from here all the way down, I have the 2 flip-flops are giving the same thing. This is very, very stable. What will happen if my main source has a glitch? It went down. Flip-flop 1 will not the same as flip-flop 2. When those are not identical, what will happen? If those two are not identical, the exclusive OR will go high. When it goes high, the n bit counter is cleared. When it is cleared, the enable signal is 0. So flip-flop 3 is not working. So no output.
I see.
Okay.
So is this more like
But if those two are identical, for long time, and for that very long time, I have the clear signal is 0. So the n counter is counting 1, 2, 3, 4, 5, 6. And all of a sudden, I had a glitch from the input. So FF1 not identical to FF2. So I clear my n bit counter. I am back to 0. When they are identical again, I will start counting for 1,000. 1,000, that is long time enough to make sure that I have flip-flop 1 and 2 are both identical. When I guarantee that, I move to the counter that is counting 1,000. When I reach 1,000, enable. Enable means the output that's stable in FF2 will go to D3 and come out as a result. Clear, Chad? Clear, Chad?
Yes, Professor, it's clear.
Cameron Bremen. Hello, Mr. Bremen.
Hello, Professor.
I know that you came in maybe a little bit late. Do you want me to repeat that for you? Do you want me to repeat what I said for you?
No, this makes good sense. Thank you.
Okay. Now, let's see how we may find
No, thank you.
this n-bit counter. I need this n-bit counter along with the clock to give me some time to make sure that I have a stable signal. How many bits this counter will be? It depends on many factors. First of all, for how long do you want this counter to be counting to make sure that I have a stable signal? 50 milliseconds, 10 milliseconds, 5 milliseconds, whatever it is. So I need to set or select the time. Normally, this is between 10 and 30 milliseconds. So I need this to be available for 10 milliseconds to 30 milliseconds. Okay. Now, what is the frequency? The frequency, it is the clock, the frequency of the clock. How many clock pulses per second? How many clock pulses per second? Let's do the drill. I wanna delay 10 milliseconds. And I have my clock, this one in here. It is operating at 10 kilohertz. So what is the number of clocks that counter must count until it reaches 10 milliseconds? Hello, Paige?
Yes, Professor.
If I tell you the clock is 10 kilohertz, what is the duration of one clock? One clock.
Don't we use the equation frequency is 1/t?
Yes, F, it is 1/t. So T will be 1/10 kilo. And this will make it how many milliseconds? Have you calculated it?
That
One
10
of-
milliseconds.
1/10K?
That 10 milliseconds.
No, it is 0.1 millisecond. 1/10, it is 0.1. And this K is in the denominator, it will go up and it will be milli. So it is 0.1 millisecond. Okay? Now, my counter. I wanted to keep counting up and reaches the terminal count after 10 milliseconds. 10 milliseconds. And each clock cycle, it is 0.1. How many clock cycles the counter will count to reach the terminal count at 10 milliseconds? After 0.1 millisecond, count 1. 0.2, count 2. 0.3, count 3, and so on. Now I need after to reach 10 milliseconds. What is the maximum count I would reach?
100.
Excellent. 100. Now, to simulate or to build a counter that can count from 0 to 100, how many bits do we need? How many bits to simulate 100?
7.
This is the equation I'm speaking about. This is the number of pulses. The number of pulses equals 2 to the power n. N is how many bits divided by f. That is 2n times t. That is what we did exactly. That's what we did. All what you need to do is just to find n. Of course, 2n plus 2, because I have 2 flip-flops. But this 2 clock cycles is nothing compared with the 1000 or 100. It is not going to make a big difference. That's why we say the number of counts, P, it is 2n over f. Okay? We have here an example. The clock is 50 megahertz, and I want the switch to settle after 10 milliseconds. So what I do is 0.01. This is my time, P, the period, time, P, time is 1 times 1 times frequency. I will get 500,000. 500,000, that's 2 to the power n. So from this, I can get n to be 19-bit. Chad? Hello, Chad?
Yes, Professor.
Is this equation clear?
It is, yes.
Thank you. Jose,
Yes, Professor.
is this equation clear?
Yes.
Do you want me to repeat to you what this debouncer circuit is?
No, it makes perfect sense.
Okay.
Professor, I actually have a question on that.
Okay.
If one more side up on the debouncer.
Go back.
Yes. If I were to add another flip-flop, would it be on the left side of the M-bit counter or on the right side?
You add 1 flip-flop extra.
Yeah, or like 3 more or 5 more. Would they all be going into
Why?
the same XOR?
Why do we need it? Why do we need it?
I don't know, just theoretically.
No, we need just two, but if you add one more, it was gonna be before the exclusive OR, and in this case, I need another exclusive OR.
Okay, and it would still be going into that same n-bit counter?
Yeah, yeah.
Okay, thank you.
The output of the two exclusive OR is exclusive OR again to feed.
Gotcha.
Okay. This is a system, debouncing system. And here I am using this to avoid any bouncing that may happen from the switch. I have the same thing. Two D flip-flops, exclusive OR, n-bit counter, D flip-flop. This is my system, and this is my push button that I wanna debounce. This is my end. I have those signals, internal signals. And you can see the counter set. Flip-flop 0, flip-flop 1, XORed. Now, if clock event and clock is 1, then the flip-flop, will take the button, and the output of flip-flop will go to flip-flop 1, output of 0 will go to 1, and counter set is 1. This means reset the counter. If it is 1, the counter will be 0. If not, it will increment.
Can I ask a question? Based on the
Yes.
formula, is it possible to change the clock frequency and have the formula still work without changing any of the other variables?
If you change the clock frequency,
Correct.
and this period is the same, this is the safe period for avoiding debouncing. This will be the same also.
That's my question. Yeah.
If both of them are the same and you want to change n, what do you want to change?
Just the frequency. If we could do it just by changing the frequency, not n, leaving n the same, it would probably spit out a different period then, I suppose.
Oh, you mean if you change the frequency, if I make the frequency, you mean you want to keep n, correct?
Yeah.
Keeping n.
Yeah, is that not possible?
Okay.
Did I break the system?
If I change f, I must change b.
Okay, got it. That does affect.
Back to our program, I'm incrementing the counter. And here I reached my output. Result will be flip-flop 1. Please go through this program line by line and take your time reading it. Okay? And then I want you to write it down. Okay? Write down this program and run it. Then next week we'll be speaking about clock domain. I'm reminding you tomorrow we'll have our second quiz. We are not going to have a class. You just open the announcement. You are going to see quiz 2, answer it, and upload to quiz 2. I'll give you 20 minutes to work on this one. I stopped sharing the screen, so any one of you may share the screen and discuss the program with anybody else. I encourage you to work together. Cameron Castello,
Yes, President.
you have your cell phone?
What was that? Sorry.
Do you have your cell phone on you?
Yes, it is.
Okay, waiting for your phone call now.
Okay, give me 1 second.
not seeing that page of code for the switch debouncer in the slides. Does anyone know where it is?
I don't know where it is. I worked on finding a different switch to bouncer code.
You got my slides, lecture 5?
Yes, that code is not in the lecture 5 slide, so
How come?
I'm not sure.
This is slide 14.
Let me check.
I just re-downloaded the slides from Canvas and they don't have the code in them.
You don't have slide 14?
There's a slide 14, but it's a different slide with different information.
Okay, okay.
Professor, you think you can post the code as an announcement or something?
Just a moment. I am gonna give me 1 sec. Announcement. Hmm. Please check your announcement. Have you got it? Hello, Vitali. The announcement.
Yeah, so they're just downloading right now. I'll let you know if I see it. Thank you.
Okay, and check slide 14. Let me know if you have it.
Will do,
Okay,
Professor.
thank you.
Perfect. I have it, Professor. Thank you.
Okay, thank you all.
So I did make it.
Hello, Jose.
Yes, Professor.
The bouncing switch, ready to share?
I'm struggling a little bit with it.
Chad. Hello, Chad.
So he went to the bathroom real quick.
Okay. Vitali?
Yes, Professor, I can share.
Okay, go ahead, please.
So this is the one issue that I'm having. Let me just close this really quick. Okay, so this is the bouncing code, as we saw here. We have the flip-flops 0 and 1 XORed in order to check if they're the same or if not, because then we have the counter that's going to determine whether to start counting or to reset, which is given by these if statements here.
Yeah.
So, if the clock is 1, then it's dependent on the signal being input to the flip-flops, and if the counter is set by the reset, then the counter, as we see, and all the other values go to 0. But right, here's where I'm having some issues. So let me show you that really quick. I'm going to do a waveform.
Would you please all watch? If you can help him, go ahead.
Okay, so we have this here, and I just made an arbitrary clock signal of 40 nanoseconds.
The clock signal should be the same clock signal specified in the previous page.
Oh, that example?
Yes.
50?
So I believe it was what, 50?
It is in megahertz.
Yeah, 50 megahertz. Okay, perfect. That's what I accounted for, because I think in Quartus, it likes to count every, like if you see from here, this is actually no, the period would be, oh, so it should be this. In 10 nanoseconds. And I could make this very size smaller.
And the counter, it is 19-bit. So it is going to count a huge number.
That is true. So with this push button, that's what I'm confused what my signal should be. Should I make it oscillate? Or not oscillate, but become periodic, or should it be one high signal?
Yes. If you make it to oscillate at lower frequency than the clock.
Okay, maybe let's do 40 instead of 10, maybe like that.
So yes, in this case, I should get no output at all.
Gotcha.
And another run, you will make it to go up and stay for a long time. And we'll see that after it reaches the terminal count, the output will go high.
I see. Okay, so yeah, let's try running this one really quick.
Okay.
Right, as you can see, there was
Nothing.
low output completely.
Nothing.
Exactly.
Now I get the output high and let it run. Get it high after maybe 2 cycles and keep it high.
Okay.
Again, I expect to see 0 because I cannot see the terminal count here. You need to increase to make the grid size very small so you can see it.
Okay.
We need to see more points.
Sounds good. Let me-
You see here, the maximum here you have is 800 nanosecond. Can you, no, stop this, go to the end, edit
The end time.
the
Oh
end
yeah.
time.
And make this. What do you think?
What is the maximum you have?
Oh, we can do microseconds.
Okay,
I'll just do 2 microseconds then. That'll be a lot. Oh, that's a lot.
Keep in mind that for your code, it's 10 milliseconds of stable time before it will allow the output to go through.
yeah, we need 10 milliseconds.
On the clock.
No, I need total. You have specified here 10 milliseconds. Read the code, read the previous page before the code, page 13. The terminal count will not be reached until 10 milliseconds.
Oh, I see. I see.
Have you seen it?
Yes. Okay.
That's
So we need a.
quite a long time.
Okay. So let's see. 10 milliseconds would be.
To avoid that, this is gonna be way down. What will happen if I make my the number of bits of my counter instead of 19, I make it 10.
Oh yeah, that would definitely help.
Okay. Go and change the program.
Okay.
Just as I thought this mission in Modern Warfare 2 was getting a little stale, they hit me with the
Hey, Sam, you're about to go.
Let's see. Let me just do the math really quick to make sure that we have enough time.
So it cycles like every 20 nanoseconds, right?
Yes, that's exactly what I got. Okay, so we should, yeah, we can make a smaller grid time probably now. Or a smaller end time, I mean.
But the total time, the end time here, I can see it still very slow, very small, nanosecond.
Yes, but by the math for 10 bits, it should
Okay.
reach
Okay.
in 20
Run it.
nanoseconds.
Run
Okay.
it. Okay.
Still 0.
How many nanoseconds with n equal 10?
20 nanoseconds. Oh, sorry, no, 20, I think microseconds. That's why. Oopsies. I gotta cancel this one. Now we see it come on.
Okay, excellent.
Awesome. Thank you, Professor.
Just a moment, because we are enjoying this show. At 40 microsecond, 40 micro, could the input signal go down and up?
You want me to change it so that it
To
stops
go
here?
down for one clock cycle, for one cycle.
Just go down and then back up?
Yes, yes, bouncing, just little bouncing.
Let's see how accurately this can edit.
Or, sorry. Come over here at 10 microsecond and make this bouncing.
Right here?
Yeah.
I'm not even sure if I can see that. Maybe like this?
Yes.
Or is that too much?
Yes.
Okay.
I think this we should delay the starting of my output.
Hopefully, let's see.
You see, it has been started by this amount. It didn't start counting until it is stable after this glitch.
Right. So then from wherever this point is, we should say.
You see,
then
here
it waited.
it is 30 something.
Right.
30 microsecond or 35 microsecond.
Yeah, by the math, it said the wait time was.
If you make another glitch, it will go further down.
All right, I'll do one right here so it's evident.
Okay.
Oh, wait. Yeah, we can see this from this point to this point. It's now 20 microseconds.
Yep.
Wow, that's cool. I get that now. The waveform helps. Very nice. Wow, I can see what you mean now. So if the push button creates enough delay, that's it. Your signal is entirely delayed.
Yes, that's correct.
Gotcha.
So please, I want you to reduce the number of bits of the counter from 19 to 10. And there is another place you have to take care of. There are two places in the program that you need to make them 10 and then play it according to this. Yes, thank you. Those are the two spots where you need to change the counter. We are counting 10 down to 0. Okay?
Awesome.
I believe now we need to continue. Those who didn't finish this one, they should work on it. In addition, I need the program with the generate. This is for today. And as I reminding you again and again, tomorrow is our quiz.
Professor, what is our quiz on? Like,
Like the
topic?
first quiz, similar to the first quiz. You will get a problem statement. You are to convert it to VHDL.
Okay, thank you.
Thank you. But I believe that this time you are not going to get the same shock. You are used to it.
I hope not. We'll see.
But anyway, I'm not going to be around.
You're not gonna what? Sorry, one more time.
I'm not going to be around.
Oh, I see. Okay.
Are we gonna have until like 5 p.m. again, or is it just gonna be 1 hour?
Let me check.
Some students have other labs and other classes, so make it long enough so if they have to run the class, they'll have time to come back and work, if you would, please.
You you want it to be 5 p.m. Okay, 5 p.m.
Thank you.
Thank you all. It will be available for you. You can read it starting at 11 o'clock in the morning, and it will be available until 5 p.m. tomorrow. Done.
Thank you.
Thank you all.
Professor, for this debouncer, did you need me to send it to you, or is just to show you that it works?
No, it is for you. Not I want to just make sure that you are gaining this knowledge because you are going to use it later on.
Okay, perfect. Thank you.
That's why I'm pushing it, because you are going to need it. Jose?
Yes, Professor.
Could I get you Coke or Pepsi?
Sure.
Sure. Okay. Do you like Coke and Pepsi?
Yes, please.
Okay. If you like them that much, why didn't you finish the vending machine?
I'm still working on it. I was like done with the codes. I can show you my codes. No, but the only thing is like I needed to run it. I got some errors, so that's why I couldn't finish it.
Okay.
But I'll for sure finish it by today.
Vitaly,
Yes, Professor.
I'm still waiting for your soft drink from the
Yes.
vending machine.
I was kind of the same boat as Jose. I had a few errors, but I'm fixing them out, and then I'll definitely get it to you with the waveforms.
Okay.
I drew out my state diagram, so I know how it works now. I just have to correct it.
Okay.
Thank you.
And as you may know that we need to use the state machine for solving this. State machine. It would make it easier. please, if you have any old assignment and you finished this debouncing switching, work on it. Okay, and you may share the screen, discuss any old assignment or this assignment with anybody. Thank you. How is it going, Jose? Hello,
I made progress on it.
and it's working?
Well, I'm not fully done. I'm still like reviewing the code, so I know for sure it works.
Okay, okay. How is it going, Paige?
I actually did have a question. I was just doing that program from yesterday where we're importing the D flip-flop. And I was looking at the code you gave us to do the register. And it's asking for in the register, it's where is it? Hold on a second. It's asking for a reset, a clock, enable, and D and Q, but I didn't in my D flip flop that I have. I only had a D, Q, and a clock. So would you like me to take out the enable and reset?
First of all, just a moment. You may share the screen,
Okay.
but before you share screen, I will share the screen first and ask you a question.
Okay.
For your program, where is it?
What program?
Yes, just one, just one. Can you see my screen?
Yes.
Have you followed those steps?
Yes.
Okay, so you have
I have
two files, one small one that is the shift register and the big one. Okay, now
I think so, at least. I could be wrong, but so I have my okay, I will share my screen.
please look at her code and try to help her.
Okay. So right here, I typed in the majority of the shift register, then I stopped because I got confused because my D flip-flop, which is here, I believe. Yeah, it doesn't have the reset and enable. And then I thought, okay, maybe I go to the lecture and find the other ones, but I didn't see one that had all of the items on the shift. And so
you made the program I gave you and the program you made are both identical or different?
they're different.
Okay, make them identical.
What?
You have the program code that I gave you.
Yes, and
not here in the lecture.
Yes, and that's what I'm looking at right now.
Okay.
I have the
And
D
you
flip-flop.
need the D flip-flop to match it.
Okay, yes, but what D flip-flop should I be using? Because there's one with an asynchronous clear, a reset, enable, but then the one on lecture uses reset, yeah, wait, enable and reset, and I don't see one that has that.
If you don't
I'm
have
not,
that, you may generate a new D flip-flop that will use all of those.
okay, I didn't know if there was one that I was supposed to.
No, you can update, you can change your D flip-flop to match this one. It should have D and clock, enable, Q, RST.
Okay.
The same letters, the same
Professor?
letters. Yes, sir.
May I share my screen because I'm exactly where Paige is right now?
Okay.
Okay, let me share.
Sure.
Okay, so you guys see this right here?
Yeah,
All right, so this is my D flip-flop that I've modified, but Professor, I'm getting an error. It's saying that my top level design entity for DFF is undefined, even though I've modified it. So this is the generate shift register with the code that you gave us. Right, so you have the port map where you basically connect the inputs from the small model, AKA this one right here, to the current model, where we obviously have, you know, a clock, DIN, shift, connect, and reset, just like here. But these ones right here, the D input, the clock, the reset, the enable for shifting, and the Q output, these are the outputs pertaining to the small model, which are here. And so I went and made those, and I made them just an 8-bit shift, 8-bit flip-flops, or 8-bit shift register, I should say, with 8 flip-flops. So 7 down to 0, 7 down to 0. And I created my signals, and then I prioritized the enable first, and then my reset. And when I try to compile it, the top level entity is defined here. But this is what I get down here. Is that top level design?
Where is your main program?
Like the small one or the big
The
one?
big one?
The big one's right here.
Do we have here what?
I know when I used DFF for the
This is,
D flip-flop, it didn't work, so I had to rename it D flip flop like something
Actual
else, and then
D flip, or okay, I see what you're saying.
because I think DFF is like a something.
It's
in the
probably
program.
something within the libraries, yeah.
Yeah,
You're right. I just named it because,
that's what
well,
the code said.
I guess when we cite the component, we just have to change the name to whatever it is.
Make
Yeah.
it DFF1, no problem.
Okay, let me try that really quick. I wonder if that would work. But
And
Professor,
are you sure that you included the small program added to the project?
I have not added it yet. That's the thing. My problem is the small program itself, because I made a new D flip-flop program, like Paige was saying.
Yeah.
The small program itself is not compiling because it says that, oh, it literally says right here, entity DFF will be ignored because it conflicts with Quartus Prime primitive name. Boom, okay, so there's my problem. So, okay, Professor, since I've already created a folder, a subfolder called DFF for this.
No, there is no subfolder called DFF. This will be under the main folder. It is not going to be a subfolder. Please read my instruction. I didn't
see.
ask you to make another subfolder.
Oh,
It is
I see.
one
Okay.
folder.
So let me show you this then. Okay, so this right here, the gen shift register, is the big program.
Yes.
Are you saying that this DFF folder should be inside of this?
It is not going to be in a folder. It is going to be thrown out here under this. It's going to be part of the project.
Oh, okay. So you're saying under gen shift register,
Yes.
which I have right here.
And it is not going to be in a subfolder.
You're saying, so under the big program, I go to project and then add current file to project, or add or remove files in project.
Yes.
And then add this small program into that.
Yes, which should be under the same folder, under the main folder.
Gotcha. Okay, so let me copy this really quick. I just want to see if this will work. I'll be so happy.
So I have my like the big project saved in the project of the smaller like D flip flop. Would that work as well? As long as they're in the same-
As I told you, read my instruction and
Yes,
follow it
I
to the
did.
letter.
I did. I was just wondering if that would be able to work.
No, it should be one folder called the
Yes.
shift register, and beneath it, you have a main program and you have the small program.
Yes, right. So as long as it's saved under the same folder, you can use it in either one.
Yes,
Okay, that was
the
my
main
question.
program, we'll call it because it is under its subfolder and both of them are added to the project.
Okay, perfect.
So, Professor,
I have to stop here. As I told you, I have another class and we have conflict. So I will have to go and I will see you next week.
Professor, just really quick, if I can like just show you this. So this is the Gen Shift Register program. You're saying if I go to project and then add or remove, basically where would
Yes,
I,
here
where would
on
I
the right
implement
hand
those?
side, you select the file name here.
Yes,
File
but
name,
does it need to belong to a folder?
file name. Select the file.
Oh, you mean this one as is?
No, select the file. These three dots to the right.
Oh, okay. And then this one?
It should be not here. I told you move the file from here, put it under the big one.
So put it inside this one?
Not the folder, the file itself, but the file by itself.
But how can you create two files?
The small file, where is the small file?
I think just the project, put the project under there.
Oh, I see what you're saying. So you literally just want me to do this? Move this one over there? Okay.
That's
let
my
me-
understanding.
Gotcha. Okay, so let me just get a new window for that.
I'll let you work together and I have to go.
Okay, thank you,
Okay.
Professor.
Thank you.
I'll keep it open for you.
Awesome. Thank
Thank
you,
you.
Professor.
Thank you, Professor. Have a great day.
All right, so if I understand correctly, he just wants me to move the D flip-flop one. This thing. Oops. Into here.
That is what I think, but I don't know because he didn't say anything.
Let's see if it'll show me all files. Okay, perfect. There it is.
Yeah, so I think that's what I did. I haven't gotten mine to compile yet because I didn't know we had to like modify the D flip flop.
True. All right, now I can select it there. Then add.
Sure.
All right, perfect. Okay.
All right.
But it should show up right there.
Yeah, I think that's it. Oh,
Do I just hit okay, or do I have to double click it or something?
well,
I thought it was added,
yeah, that's my
because usually it shows up like right here as a separate file.
right.
Not that one. Oh, maybe it needs to be the VHDL file because it's QPF.
That yeah, that would do it.
Yes. Okay. Let me check my folder really quick. Oh, I copied over the wrong file. That's why. Okay. Should be this one.
Yeah, he's throwing me off when he keeps on using the word file for other things.
Mm-hmm.
So it's like, oh boy.
Oh yeah, I hear you.
Wait, did you say when do we need to turn this in?
I don't
As
think
soon
it's
as
a turn in.
possible. It's just to show him that it works.
Oh,
But
wait.
it's really important to show that it works because I think we'll have to use this like stuff later.
Yeah.
Wait, so this is not the soda machine thing?
Now
No.
let me try this. There it is. Should be this one. Yes. And then apply maybe?
That seems right. Well, shouldn't there be two files right there?
Yeah, but the other one's already open, so. Wait, maybe I do have to select both, you're right. Fine. This one. And I'm
And then
confused
I
what I
also
do from
don't-
here.
Yeah,
I think I hit add, okay. And then. Maybe just,
applying, okay, yeah.
so
Damn.
weird, it should be here. I bet you there's just one thing that I'm not clicking.
Right. Because, well, I think you imported it. What I know at one point we use like the top, like the left bar there, where it says hierarchy. And we just
Where's that again? In the
down.
project? Right here?
No. Yeah, that works. Or the yeah, right there.
Oh, this one, I see.
You know what I mean?
Oh, dude, no way.
Perfect.
Bro,
Yes. Good
are
shot.
you joking? That's so funny. Well, let's see if it'll compile though, because I did my best to combine, the clock reset enable D and Q.
Right. But you also
Cool.
need to change your D flip-flop name too.
You're right. I wonder if I can change it now. If that'll
Yeah, I
mess
don't
it up
know.
or if that'll be okay. Like that one. Maybe that.
Yeah, that's what I did.
Well,
Oh,
I created a text file instead.
yeah.
Oh shoot, I think it got saved as a. Here. Let's try this real quick. Yeah, save as. It was literally saved as a text file. Try that.
Okay.
Yeah. Sweet. Renamed it.
Yep. And then change your labeling of the.
Right. But let's see because is this selected in here? I guess no, I guess it reads this program as this. Yeah, it'll select it.
Okay.
That should be all right.
Yep. And then you go to the other one and change the DFF to D flip-flop.
That should be all the places.
Nice. And then I don't think you need to change that first
I
one,
don't-
second one.
Yeah, I would agree.
All right. The moment of truth.
What
Just
about
kidding.
this
One more.
Yeah. I think that should be everywhere.
Right.
Okay. Oh man, please work. That would be crazy.
Come on. Oof. Okay.
Did begin and end it.
Yeah.
Maybe I didn't compile this first.
Oh yeah, that would make sense. Yeah.
But it's compiling the gen shift register instead of this now.
Huh. Well, it looks like you have 3 files in there right now, like that bar to the left.
True. I gotta
And I
remove
don't
this one.
know. if that would do something. It might not, but
I just want to analyze current file. What? Oh, it's back to this one. Maybe it is pertaining to this.
yeah, maybe.
Let's spread this out. It's hard to see.
Did you start like your G1 somewhere? Because it says end generate G1. Do you need to say like a begin? Or is that,
I thought it was part of this right here.
that's what I thought, but
It says
I
generate.
could try it. and see.
True. I mean, I've copied this as his code,
Okay,
but let's try it again.
dang. Are your variable names the same?
Should be.
Uh,
D clock and Q reset. D, Q, and clock reset. Yeah.
okay.
No, I'm just gonna save this.
And ask him.
Yeah, and come back to it.
Yeah,
I ask Cameron too. He's the goat.
right?
I feel like he would know. I feel like maybe I did mess this up, but
Yeah.
yeah, I'll look at it again. I'll let you guys know.
Okay. Cheers.
Alrighty.
All right.
Yep. Have a nice day.
Oh. Yeah, you too. See you guys.
Yeah. See ya.
See you. See you. Have a good day.